Good morning. Today we are going to discuss about the sedimentary structures and the sedimentary mineralogy. In the last session, we have seen about the sedimentary textures, and now this topic is about the structures existing in the sedimentary rock. Sedimentary structures are the larger, generally three-dimensional physical features of sedimentary rocks. They are best seen in outcrop or in large hand specimen rather than through a microscope. So what actually sedimentary structures are? They are the larger, means they can be seen by naked eye, three-dimensional physical feature of the sedimentary rocks. These are the three-dimensional physical features of the sedimentary rocks which can be seen by naked eyes, and it can also be observed in the outcrops as well as in the hand specimen. But these sedimentary structures are not so prominent or not visible in the microscope because they are not microscopic. They are larger structures, and hence they are best seen in outcrops in the field or in the large hand specimens. The different processes or the different evolutionary steps of the sedimentary rock, of a specific sedimentary rock, develops different kind of sediment structures on it. The different environment in which the sedimentation is going on, or the different agencies responsible for the formation of the sedimentary rock will definitely develop different kind of structures. So basically, sedimentary structures includes features like bedding, ripple marks, fossil tracks and trails, and mud cracks. These are the major sedimentary structures what we can see in the outcrops or the large hand specimens. Let us see the first, bedding. In the picture above, you can see that the bedding structure of the sedimentary rocks. Here you can see that the different layering or the different type of sets are arranged in the rock bed. You can see here these striation or the lines are inclined somehow. And you can also observe that there are the different sets of this inclination. If you go from bottom to up, you can see that there are 1, 2, 3, 4, and 5 different orientations in which three are three have a different set of orientation, whereas two have the another different set of orientation. So this kind of bedding is called as the cross bedding. How the bedding is developed? When the sedimentation occurs layers by layers. First, a layer will come and will deposit. Then, after some time, the another layer will come, and in this way, the layer by layer deposition of the sediments develops the bedding structure. Beddings are the characteristic of the sedimentary rocks because majority of the sedimentary rock indicate this kind of structure. Now, it also depends upon the sedimentary environment. If the sedimentary environment is quite stable, then you will have the parallel bedding. You will not have any distortion in the bedding. But if the sedimentary environment is unstable, if the currents are changing frequently, accordingly, the sedimentary beds will develop different kind of orientation. Here you can see that the difference between the two different orientation is that the sedimentary environment alteration. When the sedimentary environment altered, the angle of deposition changed, and because of which such type of cross bedding has been developed. So the bedding is nothing but the layering of the sediments, okay, which are developed, and they are altered on the basis of the sedimentary environment. And these are the characteristic feature of the sedimentary rock. Ripple marks. Ripple marks are quite common in sedimentary structures or in sedimentary rock, but not as common as the beddings. What the ripple marks are, you have seen in the beaches or where the ocean meets or the sea meets the land, there the sea or the ocean develops a current, okay, the wave currents. Because of those wave currents, the ripple marks develop over the sand. Similarly, wind can also develop the ripple marks. You have seen in the deserts that the ripple marks are developed on the sand layers. So these ripple marks, when preserved in the sedimentary rocks, then those are called as the ripple mark structure. In the picture, you can see that there are the ripple marks over the sedimentary bed. These ripple marks ultimately depends upon the type of waves or the type of agencies who are responsible for its formation. Of course, the marine ripple marks will be different as compared to the riverine or the lacustrine ripple marks. All ripple marks are different, and accordingly, we can identify whether this rock is formed in the marine environment or in lacustrine environment or in riverine environment. Lacustrine means the lake environment, riverine means in the river, whereas marine means in at the edges of the ocean or the sea. Mud cracks. These are much common features you can see even today when there is a scarcity of water in the soil, mud cracks develop. Say, for example, if your sediments are depositing in the depositing ground and suddenly the environment changed, the submergence finished, and the continuous exposure to the sun or the heat, the water evaporated, and because of which the cracks will develop over the sedimentary layer. But if again the sedimentation occurs, if somehow the water comes and again sedimentation occurs over those mud cracks can be seen preserved in the sedimentary rock. So these are the example of the mud cracks. You can see in the picture how the mud cracks can be observed in the sedimentary beds. Track and trails. See, the track and trails are not exactly the sedimentary environment related structures, but these are the structures which are developed because of the biological activities. You can see on the one picture the tracks are there where animal was walking on the immature sediments, and his footprints are developed over it. So these are called as tracks. Whereas the trails, you can see that a continuous sequence of the movement of the biological activity. You can see over there. It can be classified as the trails. So, what are the exact significance of these different sedimentary structures? Sedimentary structures plays a very crucial role and has a very great significance in the chronology. Say, for example, we'll go towards the mud cracks. As you know that the mud cracks are always formed on the surface of the sediment which is facing towards the sun. So if the sun is facing towards the sedimentary layer, the mud cracks will develop over it. And if you will find the structure of mud cracks in any sedimentary bed, you can definitely conclude that the layer on which the mud cracks are there will be facing towards the sun. So you can ultimately observe the orientation of the sedimentation, means which portion was below the bed and which portion is up on the bed. So ultimately it explains the orientation of the bedding plane. The another significance is like, say for example, if you are discussing about the ripple marks, as I have already told you that the ripple marks made by different agencies are quite different, and hence you can observe or you can see, you can conclude that the ripple marks of the concerned agencies, and you can classify that this rock is formed in that specific agency or that specific environment. So, for example, if the ripple marks are correlating to the marine ripple marks, then you can see that those beds are formed in the marine environment. Whereas if you find that the ripple marks which are much resembling to the lacustrine environment, then in that case you can say that this rock was formed in the lacustrine environment. So sometimes you can also observe or you can also identify the origin of those sedimentary beds on the basis of the structure. In the bedding, you can see that the significance of the bedding planes itself explains the environmental change over it. So, on observing the bedding stratas, you can ultimately conclude much about the sedimentary environment the bed has experienced. So, the sedimentary structures has a very vital role in different kind of scopes of the sedimentary petrology. Now we'll go towards the mineralogy. The mineralogy of the sedimentary rock is quite simple. It is not so complex. The first thing you must understand that the sedimentary rocks are found, the clastic sedimentary rock to be specific, are found by the transportation, erosion, and deposition. So if the transportation, deposition, erosion is concerned, so it can be observed that only those minerals which are resistant to weathering and erosion can ultimately survive the such kind of wear and tear. Say for example, if the mineralogy is quite weak, or if the minerals are quite weak or less resistant to the weathering and erosion, then of course they will not be able to reach the final destination. They will get wear and tear and they will be removed or they will get dissolved in the water. But those minerals which are strong, which are resistant to the mineralogy, resistant to the weathering and erosion, they reach the ultimate destination. And because of which the sedimentary mineralogy is dominated by certain minerals which are resistant to weathering and erosion. Say, for example, silica. Silica is quite dominant. It is quite strong and resistant to weathering, and because of which majority of the sedimentary rock can consist of silica. Hence, the sandstone, shale, and many of the other major rocks contain silica. Whereas if you see that the olivine, amphibole, and pyroxenes are quite less resistant to the weathering and erosion, and because of which their occurrence is also very low. So this is the triangular diagram of the sedimentary petrology. You can see here that the three corners are assigned to SiO2. It is silica. In the another corner, you can see that CaMgCO3. It is kind of carbonate corner. And on the other side, you can see here the aluminium, iron oxides are there, hydroxides are there. It contains the another corner. You can see that the majority of the rock occurs towards the corner of the silica, like sandstone, chert, argillaceous rocks, limestone, dolomites, sandstone, chert, and argillaceous rock, limestone, dolomite, argillaceous rocks. Then when you go down, then you can see that laterite and bauxite is there, which are much lesser in proportion. Okay, and if you see here in the corner of the carbonates, you can see limestone and dolomite for a certain area, but a majority of the area below the triangular diagram or at the downside of the triangular diagram where the carbonate and the aluminum iron hydroxides are there, sediments rare or non-existent. Means usually they won't exist. Why? Because they are not resistant to this weathering and erosion. And as you know that the silica is quite resistant to weathering erosion, majority of the sedimentary rocks falls near the silica corner. But the sedimentary rocks like of chemical origin, organic origin, or of residual origin are uh, can be seen in the corner of the carbonate and the aluminum iron oxides and hydroxides, like laterite and bauxite, which are the residual sedimentary rocks, whereas the limestone and dolomite are the what we can say is a chemical sedimentary rock. So this is the general brief of the mineralogy you can see in the sedimentary petrology. So first and the most important thing you must understand that the only uh, minerals which are strongly resistant to the weathering and erosion process reaches the destination, and because of which majority of the sedimentary rock consists of those minerals which are resistant minerals. And the best example is silica. Silica is quite resistant, and hence majority of the rocks contains the silica. Okay, so this was all about the sedimentary structures and the mineralogy of the sedimentary rock. So I'll just revise it in a minute. So this session was about the sedimentary structures and the mineralogy of the sedimentary rock, where we have seen the sedimentary structures, where the sedimentary structures are the large three-dimensional physical features of the sedimentary rock, which are easily seen in the outcrops of the hand specimen. The best examples are bedding, ripple marks, fossil tracks, trails, and mud cracks. Then we can see the bedding. Beddings are the different kind of sedimentary beds developed over the sedimentation process, because the sedimentary rocks are found bed by bed brought by the agencies, and the change in the sedimentary environment will definitely change its orientation, and because of which the cross bedding or the laminar beddings are developed. Then we have seen the ripple marks. Ripple marks are developed by the marine, lacustrine, and riverine environment. Okay, so different environments develop different types of ripple marks, and accordingly you can identify in which environment the concerned sedimentary rock is formed. Mud cracks are developed because of the intense heating of the surface of the sediments, and the mud cracks also have a great significance to identify the orientation of the bed. Then we have seen the track and trail. These are not actually related to the sedimentary environment. These are the features concerned to the biological activity over the immature sediments. Then we have seen the mineralogy, in which we have studied the mineralogy on the basis of triangular diagram. You can see that there are three corners of silica, carbonates, and aluminum iron hydroxide and oxides, where you can see majority of the sedimentary rocks are concentrated towards the silica rich corner, because silica is resistant mineral to the weathering and erosion, and because of which majority of the clastic rock contains silica, whereas those rocks like limestone and dolomites, laterite and bauxite, those are either of chemical origin or of residual origin or of organic origin. So this was all about the mineralogy of the sedimentary rock. So if you have any question, you can ask me, or you can put in the WhatsApp, or you can put in the chat box, or I'm also sharing the link for the remedial coaching. If you feel any doubt about this class or the class what we have executed priorly, you can put any question from any class through that remedial coaching link. Okay. So thank you very much for your patience listening.